Today, we're going to unfold a story that connects a really, really old art form with the absolute cutting edge of modern technology. And believe me, this connection is way more powerful than you might think, and it holds a huge lesson for innovation. So let's dive in. Okay, so at first glance, this just looks like a paper crane, right? But those blueprints on it, they hint at something much, much more complex. This is actually the key to a puzzle that connects three super advanced, and you'd think totally unrelated fields of engineering. First up, space exploration. I mean, just think about the sheer challenge of getting massive structures up into orbit. The solution is to design these enormous solar arrays. We're talking the size of a building that can fold down into a tiny package, small enough to actually fit inside a rocket. Then you've got advanced medicine. The engineering puzzle here is how do you create microscopic medical devices, things like stents, that have to travel through our tiny blood vessels, pop open at exactly the right spot, and then expand to perform a life-saving procedure. And finally, there's robotics. But we're not talking about your typical rigid machines. We're talking about flexible, adaptable robots that can swim through water to gather environmental data, literally changing their shape to get around obstacles. So what is the common thread tying all of these engineering marvels together? It's not some new wonder material or a supercomputer. It's the mathematical principles of origami. Yup, the ancient art of paper folding is a core tool for modern innovation. But the story, it gets even stranger. Because, and this is where it gets really wild, it turns out origami isn't just a design inspiration. A huge breakthrough in 2023 proved it has this hidden, fundamental power. It can actually compute. Now, to really get what a big deal this is, we need to talk about a concept called Turing complete. It goes all the way back to Alan Turing's idea of a universal machine in 1936. Basically, it means a system is so powerful that it can, in theory, solve any problem that a computer can solve. It is the absolute gold standard for computational power. And what's just incredible is the company Origami now keeps. You see, computer scientists have discovered that other really surprising systems are also Turing complete. Things like the video game Minesweeper, the card game Magic the Gathering, even this little simulation called Conway's Game of Life. And now, as of September 2023, we can officially add paper folding to that very elite list. So how on earth is that even possible? How can folding a piece of paper actually perform logic? Well, the mechanism, at its heart, is beautifully simple. Let's break it down. So it all boils down to this really clever direct comparison. You know how in a normal computer, the most basic unit of information is a bit, a 0 or a 1? Well, in an origami computer, the basic unit is a pleat in the paper. If you fold that pleat to one side, it represents true. Fold it to the other side, and it represents false. You've got a physical binary system. And that allows you to run a whole computation in 3 steps. First, the input. That's encoded by the starting direction of all your pleats. Second, the processing. This happens through a series of super complex folds, which they cleverly call gadgets, and they work just like the logic gates on a silicon chip. And third, the output. That's just the final direction of one specific pleat, which gives you the answer. You know, this didn't come out of some massive 10-year, heavily funded project. Nope. The story behind this discovery is a perfect case study in what happens when curiosity and different fields just happen to collide. It all started back in 2021. A mathematician named Zakharevich saw a video about some other system being Turing complete and just thought, wait a minute, origami is way more complex. It should be too. So she sent a cold email to Thomas Hall, a total expert in origami math. And just 2 years later, boom, they had a published proof. And this quote from Hall just says it all, right? He said, she just emailed me out of the blue, and I was like, why is an algebraic topologist asking me about this? It just shows how unexpected this whole collaboration was. It was a question from a completely different world, algebraic topology, that sparked the whole thing. A great reminder that innovation so often happens right at the intersection of different disciplines. So what's the big picture here? What does this all mean, especially if you're a leader in tech? Well, this entire story is really about the incredible, tangible power of what might just seem like play. I love this quote from MIT computer scientist Eric Demain. It perfectly captures the old way of thinking. For a long, long time, some of the smartest people studying this stuff were doing it just for pure intellectual curiosity, because, as he put it, it seemed fun and useless. But just look at what all that useless fun led to Today, there are hundreds, if not thousands, of engineers and designers out there who are actively using that exact same origami math to create real-world mechanical structures. So here it is, the core takeaway for any tech leader listening. First, fundamental, curiosity-driven research, the kind that has no immediate ROI, that is the seed for the disruptive tech of the future. Second, your next huge breakthrough might come from a field you are not even watching. And finally, the useless hobbies that your teams are into today, they could literally become the heart of your R&D pipeline tomorrow. This story proves you can build a computer out of a piece of paper. So the real question for your business is, are you looking in the right places for innovation? Where will the next breakthrough for your industry come from?